In this lesson, we use Thevenin's theorem on a circuit with only independent sources. The target is the power absorbed by the 4-ohm resistor between terminals A and B. Instead of solving the full circuit directly, we treat that 4-ohm resistor as the load, remove it, and replace the rest of the network by its Thevenin equivalent. The first move is to remove the 4-ohm load. The remaining network is seen from terminals A and B. Everything to the left and right of those terminals will become a voltage source Vthevenin in series with a resistance Rthevenin. After that, the 4-ohm resistor can be connected back to the equivalent. To find Rthevenin, turn off the independent sources. The 12-volt source becomes a short circuit and the 3-amp current source becomes an open circuit. Looking between A and B, the left side is 6 ohms in parallel with 12 ohms. That parallel part is 4 ohms. From B to the bottom node, there is another 6-ohm resistor in series with that result. Therefore, Rthevenin is 4 plus 6 equal to 10 ohms. Now find the open circuit voltage, Vthevenin, equal to VA minus VB. For node A, KCL gives VA over 6 plus VA minus 12 over 12 equals 0. Multiplying by 12 gives 3VA minus 12 equals 0, so VA is 4 volts. For node B, the 3-amp source injects current upward into the node, so VB over 6 minus 3 equals 0. Therefore, VB is 18 volts. So Vthevenin is VA minus VB, which is 4 minus 18, equal to negative 14 volts. Reconnect the 4-ohm resistor to the Thevenin equivalent. Using the current reference from A to B, the load current is Vthevenin divided by Rthevenin plus 4 ohms. That is negative 14 over 14, equal to negative 1 ampere. The negative sign only says that the actual current flows from B to A. The absorbed power is I squared R, so 1 amp squared times 4 ohms gives 4 watts. The same result can be checked with Norton form. I Norton equals Vthevenin divided by Rthevenin. So it is negative 14 over 10, equal to negative 1.4 amperes for the A to B reference direction. The resistance is still 10 ohms in parallel. Whether we use Thevenin or Norton, the load terminals see the same behavior, and the 4-ohm resistor absorbs 4 watts. The key details are the terminal reference and the source deactivation rules. Here, the load is the 4-ohm resistor between A and B. Turning off the independent sources gives Rthevenin equal to 10 ohms. The open circuit node voltages are VA equal to 4 volts and VB equal to 18 volts, so Vthevenin is negative 14 volts. After reconnecting the 4-ohm load, the current reference is negative 1 ampere, and the absorbed power is 4 watts.